for this case, right? For this case, AX is equal to 0. AY is not equal to what? So the rules is this. When motion is allowed, there is no reaction forces. Yes. Yeah. Thank you very much. Okay, I owe you a pint. Any mistake I make, you have a pint of beer. If you are Canadian, if you are from France, also a pint of beer, not a bottle of wine. Yeah, go. Okay. I hate it when I'm having fun. That's when the problem comes. You guys know that. Right. So you can see that. Remember when I told you about when I would die when I jump from 5th floor? Yes or no? Right, when I jump from 5th floor ETV building, I was so depressed. Okay, if I jump, I will not die on the 4th floor. I will not die on the 3rd, 2nd, but I will die on the ground floor. Why? I stop falling. I hit the ground. Right? There is no what? Motion. Don't memorize all this. Okay? Just think if you commit suicide, what will happen? Okay? Okay? So that's easier to remember. Rather than this crap I'm writing, when motion is allowed, there's no reaction. Just think when you will die when you jump out from us. You think it's so much easier. Yeah? Right. I have to behave because we have visitors, okay? Now, let's look at moment now. Moment is the part that is what? It's confusing, okay? And I don't want you to be confused. So let's look at moment for simply supported beam. Okay, let's look for a moment. Right after when you guys wrote your final exam, I got COVID. And after COVID, I had flu. And I have not had a holiday. I'm a miserable bastard now, I'll tell you that. But having COVID is really good for me. I'll tell you why. I understand how you feel. Now listen, if you have any chance got COVID, let me know. Are we clear? I will extend your deadline. I'll move your term test. Are we clear? I was an ignorant bastard before. I could not understand. But when I hit COVID, I was sick like a dog. Are we clear? And ask me to do this crap, I can't. Okay, so be honest about it, yeah? Don't like term test on the 4th of February. Every father, mother, son got COVID. I need evidence, yes or no? Why are the lights dimming? Hey? Is it dimming or is it me? Better now? Yeah. Yeah, it was dimming. It was getting too romantic. I was very uncomfortable. Right. So let's look at moment. Okay. When X is at point A and X is at point B, moment at point A is equal to 0. Moment at point B is also equal to what? 0. Don't memorize this. See it physically, what is going on. Why moment at point A is equal to 0 and moment at point B is equal to 0? And it's simply supported. Okay, so now we go to a case when we remove support at point B. When we remove support at point B, what will happen to the structure? It will what? Well done. When we remove support at point B, So this is our support at point A. When we remove, right, what will happen to the structure is the structure will tend to what? Will tend to rotate. Why will it tend to rotate? Because counter moment is what? Is missing. For this case, that is why moment at point A is equal to what? You remove one support, X and Y will still be there. So it will not what? It will not move in X and Y, but it tends to rotate about the what? The Z axis. Are we clear? Okay. Likewise, if we have another scenario where we remove support at point A, what will happen now? So now we remove support at point A, we only have a roller at point what? At point B. When this is the case, the entire structure will tend to what? Rotate. That's where moment at point B is equal to what? 0. McMaster graduate has to know their boundary condition properly. I've done consulting, and engineers don't know boundary conditions at all. Okay, not under my watch. The next thing we're going to look at is cantilever beam. So in a cantilever beam, you have a structure like this, and you have a load putting down here, for example. Okay, it can be without a load. And this is point A, and over here is point B. Okay, there's point A. We know once we draw free body diagram, this is our AY, and this is our moment at point A. Yes or no? That's our cantilever beam. So when that is the case, for cantilever beam, moment at point A is not equal to what? 0. Can anyone tell me what is the moment at point B? 0 or not 0? Apply what you just learned. If it's equal to 0, what does it mean? Can you prove that it's equal to 0? How are you going to prove it? When you remove support from point A, what will happen to the structure? Okay, no. Okay, apply what we do. Is it clear now? Are we clear? Nothing difficult. Don't memorize anything. Mechanical engineers, we need to see to believe, and there's always a logic. If there's no logic, there's something wrong with me. Are we clear? Now, anyone has a ruler? A long ruler. Plastic one, please. Small one, no good. Okay, small one is good. Very good. Cantilever beam. One end fixed, the other end is free. Okay, where will you break? Where will you break? You will break where I want. I hold over here. It will always snap in this area. Okay, it will not snap at the right, at the free end. Why? When you being jump from the fifth floor, what happens? There's no reaction force. Down here, is where you have your maximum one. Bending. Are we clear? Okay. Simply supported beam. Where will it break? Simply supported beam. Where will it break? At the middle. Why? Huh? Bending moment is going to be the maximum and the where? At the center. Are we clear? Okay. Why this is important? You don't calculate stresses at every single point. As engineers, what must you do? You have to what? Use here and anticipate where fracture will what? Okay. Are we clear? If you're going to do from point A to point B, then we have to go to the Philippines. Labor is cheaper. We are too expensive. Are we clear? Okay, to compete with countries like Philippines, highly educated, we have to work what? Smarter. Are we clear? So you have to know. That's why this course is a bit hard. You have to know, and I will teach you where fracture will occur. Okay. Now, next come overhanging beam. What's the moment at point A equal to? Ask the question again. Apply what we just learned. What is moment at point A equal to? Why? This is not simply supported. This is overhanging. So when you remove B, A will fall. Yes or no? Moment at point B. Anyone? You guys know that I'm honest, yes or no? Or you doubt that? Remember what I told you guys in 2Q? What is come out, definitely come out, yes or no? I'm honest, right? And I have to be honest to you down here also. I don't know. What? You are not sure, what do you do? Be like me. What did I just say? I don't know. It's okay. I don't know everything. It's fine. Are we clear? Don't make an assumption or it's going to be equal to 0 and then it's 4. Don't do that. You have, this course, you have to be very what? Precise. You have to be very what? Exact. Are we clear? Right. So now, I hope, I know I went longer than before. Now you know about what? Boundary what? Condition. And these are the most basic ones. Okay? As structural engineers, you have to know all this. So for the next case, we are going to apply the integration method to determine our VB and our MB. I'm going to write a few equations coming out. Okay. So does this look familiar? Yes or no? So after this, when you integrate the first time, what do you get? Does this look familiar now? Yes or no? And then we integrate the second time. Does that look familiar? Yes or no? To determine C1 and C2, what do you need? What do you need? Boundary condition. That is why the boundary condition is so what? It's so what? Critical. If your boundary condition is wrong, what will happen? Everything down the what? The toilet bowl. Are we clear? I'll see you guys on Friday. Thank you.